Good late afternoon and a very warm welcome to the black hole. Today's topic is From Quarks to Humans, an overview from the Big Bang to the beginning of life. So, today we will have a fascinating journey spanning from the birth of the universe in the Big Bang, and we will reach to the point where life emerges on the planet Earth. We are very grateful to Dr. Pervez Hoodbhoy who will deliver this talk. Uh, One thing I would like to mention is that this session is happening with the collaboration of Burak Space Camp, and now I will invite Amar Mehdi to introduce Burak to all of you. Thank you.
Thank you, everyone. Hello and adab. Hello and adab. It is a pleasure to be here. So, I would like to briefly just introduce the Burak Space Camp and Burak Planetary Society. Burak Space Camp is a project to build the leaders of tomorrow, encourage in them a sense of initiative and enterprise, nurture their desire to give back, and provide them with a safe space to experience science as it happens around them. Burak Space Camp started its journey in 1993 when Chairman Dr. Shahid Mahmood had very closely observed in Uzbekistan the model of their space camps. And he brought it back home with him in Pakistan for a vision of space camps within Pakistan. In 1994, the first Burak Space Camp was held in Murray, and since then, the Burak Planetary Society has held 16 successful space camps. This year marks the 17th ever Burak Space Camp, and I am very excited to have with us a speaker who needs no introduction. He is one of the leading intellectual voices in Pakistan, not only in physics, but in a lot of contemporary social issues beyond the sciences. So please give a very warm round of applause for Dr. Pervez Hoodbhoy.
Oh, no, that's okay. Okay. Well, thank you for that introduction. Now let me introduce the black hole to you. This is something that we started 2 years ago. The idea is that we need a place where people can get together and they can talk about everything and anything. So it could be science, as will be the case today, or it could be art or culture. We have music classes over here, we have painting, drawing, sketching, talks about the economy, talks about what's going on in Gaza, and lots of things, 600 things that we've done so far. But anyway, today we're going to talk about a very big subject, how we came to be here, how you came to be here. It's a journey that took roughly 13.7 billion years, but we'll have to finish in 60 minutes, and then we'll have questions, answers from you. Okay, when you ask a question, you will have to speak into the microphone. वो इसलिए कि ये लाइव जा रहा है, फेसबुक पे जा रहा है, और फिर कुछ दिन के बाद ये यूट्यूब पर भी आ जाएगा, तो आपकी बात समझ में नहीं आएगी किसी को, क्योंकि कोई बोलता हुआ दिखाई देगा लेकिन पता नहीं चलेगा कि वो बोल क्या रहा है. So wait for the microphone to come to you, and we'll take it from there. Okay, so maybe I can start posing some questions, the big questions of life, and for that I will need my computer and a PowerPoint. Tick. All right, that's what we are going to be talking about. So the big questions are, where did we come from? Could there be life elsewhere in the universe? I mean, who knows? But we can speculate on that. The Earth, we stand on it. Whenever we put something like this, or let's say this bottle, it stands on something. Something is obviously pushing it upwards, right? So what's keeping the earth in its place? What's it standing on? And then there are questions which we won't even be able to address. Why are we here? We'll leave some questions for later, for a time when maybe we are in a better position to answer them. So let's begin with ancient views. आप इधर आ जाएं, इधर जगह है, हाँ, या एक सीट वहां पर भी है पीछे, हाँ चलिए उधर उधर आ जाएं. तो वो कदीम ज़माने की बात से हम शुरू कर सकते हैं, way back in the past, and human history is about how old? Something like 6,000 years. Of course, there were humans before that, but there's no recorded history. I'm going to begin with ancient views, and remember that all civilizations, all peoples have tried to answer these very big questions, and they have their own answers. So, well, the question of what holds the earth up, well, one answer could be that it's on the horns of a bull. है ना? बैल के सींगों पर जमीन रखी हुई है. यही तो वजह है कि ज़लज़ले आते हैं, कि जब वो अपना सर यूं हिलाता है तो ज़मीन हिल जाती है. Well, but then the question is, what is that elephant standing on? And it could be a turtle. Why a turtle? Because a turtle can lift heavy things. But then the question is, what is the turtle standing on? Any answers? The turtle could be standing on another turtle, who could be standing on yet another turtle. So it could be turtles all the way down. But then, what about the last turtle over there? Who is he standing on? And it could be a giant, a super turtle. Okay? Well, there are, in every religion, answers to how the universe came into being. And so there is the biblical theory of creation, which is very similar to the Jewish theory and to the Muslim theory. So it is kun fayakun. It happened because God willed it. Well, that's a reason, that's a good enough reason. But then not everybody believes it. In Hinduism, it is Brahma who creates the world. And by the way, the universe is not created once. It is created and then destroyed. The destroyer is Shiva. या शिव भी कहते हैं इसको. And you see, he has in his hand the Trishul, with which he goes and he destroys the world. So then the world which Brahma had created is destroyed by Shiv, and then there is chaos. There is no life. There is absolutely the world is in a terrible state. Everybody is dead. And then after a very, very long time, there is a sound that comes, Om, Om. And that's when Vishnu comes along, and Vishnu is on the back of a serpent. Actually, it's a serpent with many heads, 5 heads over here. And then Vishnu brings Brahma back. And then Brahma starts creating the universe again. And then it goes on, and then it is destroyed again by Shiv. Okay, so that was the traditional view. And I'm not asking you to believe it or not believe it. जो जहाँ पैदा हुआ है वो उसको सही समझता. I missed out something very important, that is the Greek tradition. There was a big god there who lived on a mountain. The mountain was called Olympus. Do you know the name of that big god? Zeus. Yes, good. And Zeus, and he was also, he created the world, and then the other gods got angry with him, so they used to have fights, and long story over there. Okay, but now let's come to the scientific part. So first of all, we have to ask, what do you mean by the universe? What is the universe? And you might think that the universe is all the matter that is in there. So the stars, the planets, the gas that you see around, the nebula, everything, you, me, that is the universe. That's only part of the universe. There is, you must remember, there is also space-time. So the universe must be defined as comprising of matter and space-time itself. अच्छा देखिए, आमतौर पर हम इसके बारे में सोचते ही नहीं. हम समझते हैं कि स्पेस तो है ही. स्पेस क्या चीज़ है? जिधर हम कोई चीज़ रख सकें. और टाइम क्या चीज़ है? वो तो है ही, वो तो चलती चली, वो एक ऐसी चीज़ है जो चलती चली जाती है. वक्त का गुज़र एक दरिया के बहाव की तरह है, और हम कभी इनको यूनिवर्स में शामिल नहीं करते. हम कहते हैं कि अच्छा ये तो है ही. लेकिन हम आज ये जानते हैं कि स्पेस टाइम खुद बनता है, खुद बढ़ता है, फैलता है, और इसका फैलाव असल में कायनात का फैलाव है. लेकिन इस पर हम बाद में पहुंचेंगे. एनीवे, द पॉइंट इज दैट इट्स स्पेस टाइम प्लस ऑल द मैटर, दैट्स द यूनिवर्स. कुछ थोड़ा सा मैं आपको बताना चाह रहा हूं कि जो मैटर है उसके साइजेस तकरीबन कितने हैं. तो एक एटम को हम बहुत छोटा समझते हैं ना. तो एक एटम जो है, दिस इज समथिंग, एक और दूसरे एटम में फ़र्क तो होता. ऑफ कोर्स द स्मॉलेस्ट एटम इज हाइड्रोजन. एंड व्हाट्स अ बिग एटम? लाइक लेट्स से uranium, yeah, uranium, and then there are atoms which are even heavier than uranium, like plutonium, and then unstable elements which go beyond that. But they're all, roughly speaking, the same size. It's not that one atom is this big and the other is like 3 miles wide. No, they're all roughly the same size, and that size is 10 to the power minus 10 centimeters, or 10 to the minus 8 centimeters, whichever you're more comfortable with. So here you see that this atom is roughly 10 to the minus 10. At first, so this was 130, 40 years ago, we didn't know that the atom was, we didn't know anything about its structure. But we did find that you can knock a negative charge out of that, and we call that negative charge particle an electron, and there's at the center of the atom a positive charge, we call that a nucleus. And through an experiment which was done by Lord Rutherford, in which he threw alpha particles at an atom, he found that it had a center, and that center, the size of that center is 4 orders of magnitude smaller. So 10,000 times smaller than the atom is the nucleus. Well, that nucleus is itself made up of neutrons and protons, and those neutrons and protons are of course much smaller than the nucleus, but not much smaller. हाँ, थोड़े से छोटे हैं, अगर न्यूक्लियस इतना है तो एक न्यूट्रॉन इतना होगा, या प्रोटॉन। न्यूट्रॉन और प्रोटॉन तकरीबन बराबर हैं साइज में। अब कहानी यहां नहीं रुकती, प्रोटॉन के अंदर भी छोटे जर्रे हैं, उससे ज्यादा बारीक जर्रे हैं जो क्या कहलाते हैं, क्वार्क्स। और हमारी कहानी जो है वो क्वार्क से जुड़ी हुई है, मगर ये थोड़ी देर में मैं आपको बताऊंगा। अच्छा, अब जहां तक हमें इस बात का पता है, क्वार्क से छोटी कोई चीज नहीं है। इट्स द स्मॉलेस्ट दैट वी हैव सीन, एंड so the quark and the electron and other particles, so there are, I'll tell you more about them later. Those are what we call the elementary particles. They are the building blocks of matter. These particles are held together by forces, and there are four fundamental forces in nature. फंडामेंटल से मेरा मतलब ये कि ये वो फोर्सेस हैं जो मैटर के बीच में कार फरमा हैं, और ये फंडामेंटल इस सेंस में है कि देखें, जैसे और फोर्सेस तो हैं ना, आप उनसे वाकिफ हैं, जैसा कि गिव मी एन एग्जांपल ऑफ अ फोर्स व्हिच इज नॉट फंडामेंटल। फ्रिक्शन। Friction is not a fundamental force. Why? Because it's really, so when I rub my hand this way, it's the molecules in this hand interacting with the molecules in this hand, and that is what we call friction. So that's not fundamental. That comes from these forces, in particular the electromagnetic interaction. अच्छा, तो अब मैं आपको थोड़ा सा बताता हूँ ये चार फोर्सेस क्या हैं। एक से तो आप बहुत अच्छी तरह से वाकिफ हैं कि ये जब हम छोड़ते हैं तो ये नीचे गिरता। क्यों गिरता है? इसलिए कि ग्रेविटी इसको नीचे खींचती है। दैट्स द ग्रेविटेशनल फोर्स। इस फोर्स से, इलेक्ट्रोमैग्नेटिज्म से भी आप बखूबी वाकिफ हैं। जब आप कंघी करते हैं, आजकल ख़ास तौर पे जब खुश्क मौसम होता है, तो आप देखते हैं कि आपके बाल खड़े हो जाते हैं। क्यों खड़े होते हैं? क्योंकि कंघी के ऊपर नेगेटिव चार्जेस आ जाते हैं, बाल पॉजिटिव होता है, या इसका उलट होता है, और नेगेटिव पॉजिटिव एक दूसरे को अट्रैक्ट करते हैं तो बाल यूं खड़े होते हैं। तो दैट्स द इलेक्ट्रिक फोर्स। मैग्नेटिज्म एंड इलेक्ट्रिक फोर्स आर एक्चुअली द सेम फोर्स। इट्स कॉल्ड द इलेक्ट्रोमैग्नेटिक फोर्स। अब एक न्यूक्लियस के अंदर बहुत से प्रोटॉन्स और न्यूट्रॉन्स हैं। प्रोटॉन्स एक दूसरे को दूर धकेलते हैं। जाहिर है कि पॉजिटिव चार्ज को दूर धकेलेगा। सो व्हाई डज द न्यूक्लियस नॉट ब्रेक अप? बिकॉज देयर इज अ स्टिल स्ट्रॉन्गर फोर्स, स्ट्रॉन्गर देन द इलेक्ट्रोमैग्नेटिक repulsion between the charges. That's why it's called the strong force, strong interaction. So we are done with three forces. There's a fourth force which you don't see very often. But if somehow you finished it, then the world would not function. Now you see the first manifestation of that in the following way. एक आज़ाद न्यूट्रॉन लें तो वो न्यूट्रॉन टूट जाता है, ख़त्म हो जाता है, और एक प्रोटॉन, इलेक्ट्रॉन और न्यूट्रिनो एक न्यूट्रल पार्टिकल होता, वही बच जाते हैं। आप यहां आ जाएं। अच्छा, तो वीक फोर्स क्या करता है? न्यूट्रॉन को डिके करता है। अब यही फोर्स है जो सूरज के अंदर है। जब सूरज के अंदर वीक फोर्स अमल करती है तो उसके नतीजे में सूरज से गर्मी और रोशनी और रेडिएशंस वगैरह निकलती हैं। सो नाउ यू नो समथिंग ऑफ द फोर फोर्सेस, एंड नाउ आई विल टेल यू अ लिटिल बिट अबाउट what are the basic particles that comprise our universe. They are these 18 particles over here. So there are the 6 quarks, up, down, strange, charm, bottom, top. There are these particles called neutrinos. So this is the electron neutrino, muon neutrino, the tau neutrino. इलेक्ट्रॉन का, अच्छा इसको यूं सादा अल्फाज में मैं बयान कर सकता हूं कि इलेक्ट्रॉन का एक बड़ा भाई है, वो भाई उससे 200 गुना ज्यादा भारी है. दैट्स दिस वन ओवर हियर इलेक्ट्रॉन. तो ये देखें, दिस इज 0.5, दिस इज 105, so there's about 200 difference over here. Electron, muon, and this is a still heavier brother. So this is one family here, and with them are these neutrinos. Then apart from that, there's the photon, the particle of light, gluon, Z boson, W boson, and there are 2 of these, and there's the Higgs particle, and that makes 18. These 18 particles are what make all matter. कुछ और कुर्सियों का बंदोबस्त हो सकता? Sorry, there are too many people. So I've told you about which particles exist in nature. I've told you about what forces act in nature. And this is all the matter that there is. Plus, in the universe, there is space-time. But we'll come to that in a bit. A little bit more about quarks. So, these are very strange particles in the following sense. इलेक्ट्रॉन को तो आप थप्पड़ मार के इलेक्ट्रॉन एटम में से निकाल सकते हैं. थप्पड़ मारने से मतलब ये कि आप उसको किसी दूसरे इलेक्ट्रॉन या दूसरे पार्टिकल से यूं टक्कर मारें और काफ़ी ज़ोर से अगर उसको टक्कर लगी तो वो इलेक्ट्रॉन छूट जाएगा और आज़ाद हो जाएगा. सो यू हैव अ फ्री इलेक्ट्रॉन, वन दैट कैन देन ट्रैवल एनीवेयर. Well, inside the neutron and proton, these finer particles called quarks are impossible to take out of the neutron or proton. They are only found in certain combinations where they bind together. And to break up that particle, like the neutron or proton, takes a lot of energy. Therefore, these have never been observed as independent particles. So they can, as I said, they exist in various combinations. Those combinations are different particles, different hadrons. And there are now literally thousands of hadrons that are known. देखिए, मैंने तो बात शुरू की थी न्यूट्रॉन और प्रोटॉन के साथ के इनके अंदर क्वार्क्स हैं, लेकिन जो उनके परम्यूटेशंस, कॉम्बिनेशंस हैं, उनसे बेशुमार दूसरे hadrons बन सकते हैं. तो मुख्तसर ये कि आप और मैं क्वार्क्स और इलेक्ट्रॉन्स के बने हुए हैं. और अब सवाल, और ये अगरचे उन क्वार्क्स की शक्ल ऐसी नहीं है, लेकिन ये एक इट्स अ नाइस वे ऑफ पिक्चराइजिंग देम. अप, डाउन, स्ट्रेन, चार्म, ब्यूटी, टॉप. Actually, only the down and the up quarks are present inside the neutron and proton. जो दूसरे hadrons हैं जो हमने बनाए हैं, उनमें ये दूसरे क्वार्क्स मौजूद हैं, लेकिन वो सारे बहुत जल्दी डिके कर जाते हैं और डिके होने का वक्त 1 मिनट हो सकता है या 1 मिनट का 1000वां हिस्सा हो सकता है या उसका 1000वां या उसका 1000वां, एंड इट कैन बी वेरी 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 स्मॉल. In fact, the top quark is itself not stable and was very difficult to find for that reason. इसके पीछे एक बहुत लंबी कहानी है, लेकिन हम उसमें जा नहीं सकते क्योंकि हमें यूनिवर्स के बारे में बात करनी है. और जैसा कि मैंने आपको बताया, यूनिवर्स में सिर्फ मैटर नहीं, स्पेस टाइम भी है, तो इसको हमें किसी सूरत नहीं भूलना. तो ये आया सब, ये कहां से आया सब कुछ? Came from the Big Bang. But what is the Big Bang? Why is it today that physicists believe in it and think that this is the way by which the universe came into being? I'm going to give you 3 strong arguments, and I'll begin with the history of the Big Bang. So this is an American astronomer, Edwin Hubble, and Edwin Hubble built this huge telescope, something like 100 years, more than 100 years ago, and he was looking at the distant galaxies, meaning the distant stars. जैसा कि आपको पता है ना, गैलेक्सीज जिसको हम कहकशां कहते हैं उर्दू में, उसके अंदर लाखों करोड़ों अरबों सितारे होते हैं, और फिर भी ये एक ऐसा सितारों का जमगठा होता है जिसको अगर आप दूर से देखें तो एक नुक्ते के बराबर का नजर आता. अच्छा, हबल, अच्छा ये हम जान सकते हैं कि क्या एक नुक्ता जो है वो खुद एक कहकशां है या एक सितारा है. उसके तरीके से मैं अब उसकी बात नहीं करना चाहूँगा, बट वी कैन टेल easily the difference between a star and a galaxy. Of course, if you have the resolution, then you can look inside the galaxy and you can see individual stars over there. But that wasn't possible earlier. Now it is possible because we have such powerful space-based telescopes. तो खैर ये कहानी उस ज़माने 120 साल 130 साल पहले शुरू होती है. तो हबल ये देख रहा था कि जो कहकशां यहाँ पर है और यहाँ है और यहाँ है और इस तरफ है और इस तरफ है, ज़मीन से अगर देखा जाए तो ये सारी की सारी कहकशाएं हमसे दूर भागती चली जा रही है. गोया कि इनका फैलाव है बाहर की तरफ. And he was also able to measure how fast they were moving away from the earth.
सर, कुछ स्टूडेंट्स को ना इंग्लिश में इतनी समझ में नहीं आती, वो उर्दू प्रेफर करना चाहते हैं.
अच्छा, इसका थोड़ा सा वोट लिया जाए. हाउ मेनी इन फेवर ऑफ इंग्लिश? हाउ मेनी इन फेवर ऑफ उर्दू? भाई देखे, हम फंस गए ना इसमें.
There is an audience member who does not understand Urdu, and that's it.
क्या?
There is an audience member who does not understand issue in our camp. Understand Urdu, that's it.
You know, I have no objection in all English or all Urdu, लेकिन अब वोट जो हो गया, अब वोट को हम इज्जत देंगे. ठीक, ओके. लेकिन कभी कभी उसकी खिलाफ वर्जी कर लेंगे, फिर भी माशाल्लाह लग भी सकता. ओके, सो हाउ डू यू फाइंड आउट whether a star is moving away from you or towards you? Because if something is moving away from you, then the light which is emitted gets stretched out. तो यहाँ आप देख रहे हैं कि ये वेवलेंथ यूं बढ़ गई है, यहाँ पर ये पिचक गई है. सो इन द वन केस the wavelength has increased, which means the frequency has decreased, and it's the opposite in the other case. So Hubble had this spectrometer by which he could determine whether the light coming from the galaxy is the same as would come from something that is at rest or something that's moving towards him or away from him. And what he found was this graph over here. So the further away a galaxy is from where we are observing it, the faster it is moving. You see, this is exactly what happens when a bomb explodes. बम का धमाका जब होता है तो क्या होता है? उसकी गुठली अपनी एक जगह पे रह जाती है और बाकी मादा जो है बाहर की तरफ ऐसे चला जाता. And so this is the first time that people started thinking, oh, what if we take a video? Imagine that we take a video, we are seeing the universe expanding outwards. Now that means that if we run the video backwards, then it's all going to come together into one single point. And how long will it take to run that video backwards? वो तो इसके स्पीड के ऊपर डिपेंड करता ना कि किस स्पीड पे जा रहे थे. लेकिन अगर ये कर दिया जाए तो 13.7 billion years is what you need to reverse the video, and that's the age of the universe. At the time of Hubble, it was estimated as at 14 billion. Now it's a little bit better, 13.7. So this is actually one of the most important empirical laws in physics, that the speed at which a galaxy is running away from us is proportional to the distance from where you're observing it. That's called Hubble's law. अच्छा, तो इससे फिर एक दिमाग में तस्वीर बनती है that the universe was small, एक छोटा गोला थी और वो गोला फिर फैलता चला गया. The universe expanded, and now one very important thing over here. The distance between the galaxies is increasing, but the galaxies are not getting any bigger. And if, let's say, we talk about our own solar system, the distance between the Earth and the Sun is not getting bigger as the universe expands. It is free space which is expanding, but when matter is held together by forces, then there's no expansion there. Now, I have to tell you two additional reasons why we believe in the Big Bang. One, this one I told you, it's the observation, Hubble's observation, right? Things running away from the center. The other is, and this was suggested first by George Gamow, and this was in 1938 or 39. He said, look, if the Big Bang is how the universe started, then we have to then understand that initially it must have been very, 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 very hot. And if it was very hot, that means that you couldn't have atoms. Why couldn't you have atoms? Because those atoms would be colliding amongst themselves and they would be knocking out all the electrons. Could there be just nuclei, neutrons and protons in a nucleus? No, because those nuclei would be smashing into each other as well. This means that there would be only neutrons and protons at some stage. और वो न्यूट्रॉन्स प्रोटॉन्स जो है आज़ाद हालत में फिर रहे थे. समझ लो कि न्यूट्रॉन्स प्रोटॉन्स का एक सूप था. ऐसा नहीं कि जो बहुत मज़े का हो, लेकिन सूप था. अब न्यूट्रॉन और प्रोटॉन के बीच में फोर्स होती है, मगर वो फोर्स इतनी नहीं थी कि न्यूक्लियाई उससे बन सकें, एक दूसरे के साथ जुड़ सकें. But as the universe expanded further, then it would cool, and then it would be able to, the hydrogen, the proton would be able to capture an electron, and that would be a hydrogen atom. So this is how the first calculation was made of what elements there are in the universe. So now here, this is called nucleosynthesis of the light elements. तो देखें जो भारी अंसर हैं, भारी अनासिर हैं, जैसा कि कार्बन या नाइट्रोजन या आयरन या यूरेनियम, वो इस तरह से नहीं बने, लेकिन जो हल्के अनासिर हैं, मीनिंग helium, first of all, helium is the lightest of elements other than hydrogen, right? Anyone know what helium is? It's, yeah? Yeah, and it's got 2 protons and it's got 2 neutrons. Okay, so, and there are two heliums, one which has got 2 protons and a single neutron, and one which has got 2 protons and 2 neutrons. Okay, so here you see a proton and a proton collide together. After the collision, the proton and the proton, they join together and they make something called deuterium. And this photon is radiated off. Then then similarly there's another proton and a neutron, and you have a deuteron and a deuteron. From here you get helium. And that helium can capture a neutron and become helium-4. Now suppose you were born, not now, but close to the beginning of the universe. I'd say 3 minutes after the universe was born. Then the periodic table, which you today see as something so complicated, there are more than 100 elements in the periodic table, but if you were born at that time, you would see just 4 elements. You'd see hydrogen, 75% of matter in the world at that time was hydrogen, 24.8% was helium, and the rest was lithium and beryllium. Okay, so this was a prediction. This was a calculation that was carried out. And then astronomers, they said, aha, this is something we can test. So they took their telescopes and they looked all over the universe, rather at the light that's coming from the stars, from the galaxies, and they found that prediction was exactly right. अब exactly से मेरा मतलब ये नहीं कि ना to 20 decimal figures, लेकिन 75 point something percent is hydrogen, 24.8 something percent is helium. What a brilliant confirmation of the Big Bang. तो देखें, हम जब ये कहते हैं ना कि हम बिग बैंग को सही मानते हैं, वो ऐसी कोई खाली खुली बात नहीं है. उसके पीछे बड़ी सोच है. एक तरफ तो प्रिडिक्शन है, you predict something that you don't know. Next you go out and look for that which is as yet unknown. There's a third very important thing about the Big Bang. It's called the cosmic microwave background radiation. I won't go into that. It'll take us too long, because there are lots of more other things that I have to discuss. But I'll just give you an idea of how much time is involved. So Let's say the universe starts at 0 seconds. We don't know what's before that. Let's say it starts at 0. Then, at this time, it's a ridiculously small time, 10 to the minus 30 seconds or so. Gravity becomes very different from the other forces. वो जो 3 forces है ना जिनका मैंने जिक्र किया था, there was the electromagnetic, the strong and the weak. They were like very similar to each other at that time, but gravity started being different. Also, and I won't go into this, at the beginning of the universe, there were as many particles as there were antiparticles. Antiparticles eat up particles, or you could say particles eat up antiparticles. If, for some reason, and I think we understand the reason, the two had been exactly equal, that is to say, if particles had eaten up all the antiparticles, there would be no universe today. But there's a small difference, and that is why today the world is made up of matter. The really important time is 3 minutes. There's a very good book by Steven Weinberg, who got the Nobel Prize in Physics, together with Abdus Salam. And it's called, the title of the book is The First 3 Minutes. The first 3 minutes tells you exactly what stages the universe went through. And it is when the simplest atomic nuclei were formed, which is, this is the time when the protons and neutrons were formed. So, what was there before that? Quarks. Quarks and electrons. Because at that time, earlier to 3 minutes, the universe was so hot that even protons and neutrons could not be made. Achha. So then, let me skip a few million years. You have this hydrogen which is formed, and this hydrogen is in the form of a gas. तो अब ये देखें कि हाइड्रोजन आखिर मैटर है ना, और मैटर को अपनी तरफ खींचता है, इनके बीच में एक कशिश होती है, there's a gravitational pull, as a consequence of which these big clouds of hydrogen, they started condensing, and as they condensed, they became hotter and hotter, and eventually they became so hot that a nuclear reaction started, and the first stars were born. Now these stars lived for a few billion years. The first stars were made a few 100 million years after the Big Bang. And the stars live for a couple of billion years, maybe more, maybe less. अच्छा, लेकिन देखें स्टार्स में क्या होता? आपकी गाड़ी पेट्रोल पे चलती है ना, पेट्रोल खत्म होता तो क्या हो जाता? गाड़ी रुक जाती है. अब ये जो सितारे हैं ना, ये भी, इनको भी फ्यूल चाहिए, ईंधन चाहिए. They eat up their fuel. And our sun, the one up there, eats up hydrogen at the rate of 600,000 tons per second. And now the bigger ones eat up at a still bigger rate. And then something terrible can happen as a star runs out of fuel. Instead of simply dying, it explodes. What you see over here is an exploding star. It's called a supernova. Nova का मतलब है सितारा. Superstar. This just blew up. And at the very center, there's a little relic, a neutron star, and that neutron star is rotating. It's called a pulsar. But this is an actual photograph that's been taken. It's not some artist or some, some Photoshop business. So now this stuff over here is spreading out into space. And this stuff, what is this stuff? Inside a star, you had, helium. We saw how helium was produced. When it captures a neutron, then it captures a neutron and a proton, it becomes beryllium. And then it goes on and on through capturing neutrons. Now, this is how the heavy elements came into being. So, all the heavy elements were made inside stars. ये जो हल्के elements थे ना, हाइड्रोजन, हीलियम, लिथियम, बेरिलियम, ये तो बिग बैंग के वक्त बने थे, लेकिन जो दूसरे बड़े जो भारी अंसर थे, वो सुपरनोवा के फटने से बने. And in fact, this is how the solar system was formed, including the sun. What happened was all this junk, this cosmic junk, was spread out into space. Now, junk also is heavy, and that junk started coalescing. And from that came the sun, from that came the planets, from that came you. You are, as Carl Sagan used to say, stardust. So it's incredible how we are the result of a supernova explosion. This is how all the planets were formed, and including the planet which is of greatest, which we like quite a lot, Earth. Earth, these are the stages through which the Earth was formed. अब मैं ज़्यादा इसमें तफसील में नहीं जाना चाहता, क्योंकि ये भी एक लंबी कहानी है कि कैसे इधर से इधर तक का सफ़र हुआ. But when the Earth was formed, you see, it was molten and the crust started forming. Before that, the Earth was just was so hot that there was no question of it having any kind of an atmosphere, because if something is too hot, then it'll just throw out the gases. And now, I come to the last part of my talk, and which is really the most interesting, which is, how did life start? We understand very reasonably well, actually quite well, about the universe and how what it looked like in its early stages. And we understand now how stars behave. We understand exactly what makes supernova explode. In fact, there was a Nobel Prize given to this to Hans Bethe. He discussed how shock waves inside a star lead to that supernova explosion and create all those heavy elements. अच्छा, तो चलिए अब इन बड़े सवालों की तरफ आते हैं. जिंदगी क्या है? शायराना सवाल है. कोई अच्छा शेर कोई पढ़ के सुना दे, जिंदगी क्या है? कोई कुछ? जिंदगी क्या है? एक चाक एक कफन है फाकिर, उम्र भर जैसे हम सिए जाते हैं. ये भी हो सकता. The bigger question, how does dead matter, inanimate matter, turn into life? These are things that we have now some understanding of, but which need to be understood in detail. And then, is there life elsewhere in the universe? What is the future of life on Earth? And Will we have to leave it? Will we have to leave the earth, go elsewhere? Where will we go? हमें कौन पनाह देगा? All those questions. But let's look at what we know, what has been understood through debates in different cultures. You can see that in every culture this has been thought about. How did life come into existence? Well, one thought is that it came into existence through insects and worms. That's why that makes so much sense, because if you leave some food outside and suddenly, after 3 days you will see over there that there is mold and maggots and all kinds of insects. So you say that life comes through insects and worms out of dirty stuff. In fact, in England they used to think that life came from the dirty underwear of kings. Every religion has its own view, and we discussed how this is seen in the monotheistic religions. We saw how Hinduism looks at creation, but we are not going to do that. We're just going to look at this in a biological sense, in a scientific way. And there are two possibilities here: that life originated on Earth through reactions in a chemical soup. I'll explain that a little bit more. Or else life came from outer space. Okay. That we will look at again, but first we have to ask the fundamental question: what is life? Technically, life is a chemical system that undergoes Darwinian evolution and degrades high quality energy from its environment in metabolism. मतलब ये सादा लफ्ज़ों में ये कि ज़िंदगी के लिए एनर्जी चाहिए, वो एनर्जी माहौल से मिलती है और फिर मेटाबॉलिज्म के ज़रिए से, उस खुराक के ज़रिए से एनर्जी पैदा होती है, जिससे वो जानदार फिर एक जगह से दूसरी जगह जा सकता है, अपनी नस्ल आगे बढ़ा सकता है. लाइफ हैज़ टू बी एबल टू रिप्रोड्यूस इटसेल्फ. एंड फॉर लाइफ टू एग्जिस्ट देयर मस्ट बी एनर्जी. थर्मोडायनामिक्स में हम इसको फ्री एनर्जी कहते हैं. इसके लिए हमें ऑर्गेनिक मॉलिक्यूल्स की ज़रूरत है. व्हाट आर ऑर्गेनिक मॉलिक्यूल्स? दोज विच कंटेन कार्बन. Why is carbon important? Because carbon can make a lot of friends. Carbon has got 4 bonds. It can join up with 4 different groups of atoms, or it can even join up with 2 different groups of atoms. It can behave as a quadrivalent atom or as a bivalent atom. And it can make so many different combinations that everything that we have that is living is made up of organic molecules. And of course, we need water. Water's necessary to take nutrients from one part of the cell to the other part, to take out the used material, to clean the system. And without water, it seems very difficult to have life. Well, let's now think of what was the situation on Earth before life started. So there was a lot of nitrogen gas, there was carbon dioxide, sulfur, water vapor, and very little oxygen. The oxygen came later. It was produced by plants. It wasn't there at the beginning. And of course, as I told you, the universe is mostly made of hydrogen, and so there was plenty of hydrogen around. And that was the situation on Earth. तो अगर आप कोई 3 अरब साल पहले ज़मीन पर होते ना, let's say 3 to 3.5 billion years ago that you were on Earth, this is what you would have seen. The Earth inside was very, very hot. It still is hot, but not as hot as it used to be. There would be all this sulfur dioxide coming from inside, very poisonous stuff. There'd be sulfur springs over there. Those clouds would be that of probably sulfur dioxide, I don't know what. This is an artist's impression of what would have existed then. And there would have been a lot of lightning, because where there are clouds and there is an atmosphere and there is energy, then lightning results as a results from that. Very intense lightning storms. So it seems as if it was very difficult to have complicated molecules. ठीक है, जो सादा है ना, हाइड्रोजन, कार्बन डाइऑक्साइड, सल्फर डाइऑक्साइड, मीथेन, वाटर वेपर, ये सब कुछ होगा, लेकिन उससे आगे जो बड़े मॉलिक्यूल्स हैं जिससे जिंदगी बनती है, वो कैसे बने? So these are the key questions that have been driving research in evolutionary biology for the last 100 years. The real question is, how did these simple atoms make life, and in particular, make proteins? We are made from proteins and carbohydrates and fats, and proteins are the molecules, very, very complicated molecules. So that was the question. Now there were these two scientists, Operon and J.B.S. Haldane. They were chemists, and they were thinking of this problem, and they said that this is an experiment that was inspired by their papers. It was actually carried out in 1952-53 by these two people, Miller and Urey, Stanley Miller and Harold Urey. And you see, it's a very ingenious experiment. So what you have over here is a flask heated up by a Bunsen burner. Water vapor rises up, goes into this chamber. अच्छा, इस चेंबर में क्या है? CH4, जिसको वो क्या है? Methane. Methane, ammonia, hydrogen, water vapor, और फिर 2 इलेक्ट्रोड्स हैं. जब आप इनको एक बड़े वोल्टेज सप्लाई से कनेक्ट करते हैं तो इनके बीच में एक स्पार्क गुजरता. What is the spark doing? It's simulating the lightning, जैसा कि उन ज़मानों में होती थी. So you've brought these simple atoms together and then given energy. Whatever happens, that water vapor carries it down. So here that water vapor gets made into water, and then the water is collected down there. अच्छा, अब उसको जब एनालाइज किया गया तो पता चला कि उसमें एमिनो एसिड्स हैं. Amino acids are the basic building blocks from which you make proteins. And so now the story is getting completed. We are seeing that simple atoms are combining and becoming complicated molecules, amino acids, which can become proteins. How they became proteins is still being investigated. But this is probably the thing that was most important to life, the ribozyme, and this is pre-DNA. This then brings the first living creatures on Earth. These are called prokaryotes. Prokaryotes are just the most elementary form of life that are possible. And they're so simple they don't have a nucleus. But with the passage of time, these prokaryotes then combine with mitochondria. You've studied mitochondria. You all know what that is. And from there come cells with a nucleus, eukaryotes or eukaryotic cells. This then starts the process of evolution. So from single-celled beings, you go to multicellular organisms, and then the principle of natural selection determines which survives, which doesn't. But just to tell you how long it took, well, it took 3 billion years. But we don't understand 3 billion years. अच्छा हाँ 2 ज़्यादा हो गए देखो लिखते लिखते गलती हो जाती है ना हाँ हाँ ओके राइट but here is how to understand it. If you take those 3 billion years and you say that's equal to 24 hours, then the earth is too hot between आधी रात से लेकर सुबह 6 बजे तक ज़मीन इतनी ज़्यादा गर्म है कि इसके ऊपर कोई जानदार जिंदा हो ही नहीं सकते. प्रोकैरियोट्स बनना शुरू हुए सुबह 6 बजे से शाम 4 बजे तक. तो दैट टुक a billion years. Eukaryotes उसके बाद बने because you needed that time to evolve and get DNA, single-celled animals, and then came multicellular animals. We've been on this planet in the last 1 minute. So you see how recently we've come here? 1 मिनट हुआ हमें आए हुए इस जमीन पे. तो अब मैं ज़्यादा तफसील में नहीं जाना चाहता. देखें ये अगर और पीछे हाँ, प्रोकैरियोट्स से आगे शाख निकलती है, ये आर्किया बनता है. तो ये सिलसिला जो है शाख से शाख, शाख से शाख. So this branching happens. If you just look at primates, so there are many different primates. You can see some of them over here, all the way up till human. By the way, it is not right to say that human came from apes. Humans came from a different branch. One of those branches produced apes, the other produced us. But among humans, Homo sapiens also, there were so many different other branches. There were the Neanderthals who have now disappeared. But this has been the process of evolution, and this was all in the one last minute. And the earlier forms, well, we can now picturize them. It's not empty picturizing because we have a lot of data now about bone sizes and weights and so forth. This is how the early forms of human existence probably look like. And so now with DNA testing, we actually have a very good idea of how we came to be here in G11.3. It started about 80,000 years ago, 90,000 years ago. And I don't know which particular route brought us here, but we are here somewhere. तो इसको पीछे खींचें. So We started from here. That's the end of the story. Other questions we will not be able to answer in this very short time. Are we alone? My guess is probably not, because the same things could have happened elsewhere in the universe. And probably that process, not probably, but certainly that process is underway over there. जो यहाँ हुआ ज़मीन पे वो किसी और सैयारे पे नहीं हो सकता, बिल्कुल हो रहा होगा. तो कहाँ है वो जिंदगी? It's not in the solar system. Solar system तो बिल्कुल हमारे पड़ोस में है. It's somewhere out there. Okay, so my last slide, and ये एक समरी है कि बिग बैंग से तो अब कोई अब इनकार नहीं कर सकता. इतने मजबूत दलाइल हैं उसके हक में, जो जो टेस्ट हम उसका करते हैं उससे हमें पता चलता है कि ये बुनियादी तौर पर ठीक है. इसका ये मतलब नहीं कि सारे सवाल हल हो गए. साइंस नए सवाल पैदा करती चली जाती है जैसे जैसे वो आगे बढ़ती. फिर जहाँ तक सोलर सिस्टम की बात है, we don't, this is very interesting that we don't know as much about the solar system as we know about the universe. The solar system is still sort of quite unsolved. Why is Mars so different from Earth? Well, obviously distance from the sun makes a difference, but the internal composition, why are the magnetic fields similar yet different? Many questions of that kind. So, the one last thing I will mention is, was it possible that life came from outer space? मैंने उसका जिक्र किया था ना, लेकिन फिर उसको आगे नहीं पहुंचाया. इसका जवाब हमें यूं मिल सकता है कि अगर हम स्पेस में जाकर एस्टेरॉइड्स को पकड़ें, उनसे उनकी मिट्टी उठाकर हम ज़मीन पर लेकर आएं और देखें कि क्या उनमें कोई जानदार हैं कि नहीं, तो इस सवाल का जवाब हमें मिल सकता. It's possible but not probable that life, or rather the early form of life, arrived from outer space, but when it reached Earth, because of the good environment that we gave to life, that life was able to develop. I mean, these asteroids can land on Venus, but they will get cooked. It's too hot for life over there. Whatever view you take, remember that it all happens through the process of evolution. Evolution is the cornerstone, is the basis of biology. How we develop from simple to complex species, Darwin tells us that. Okay, so I'm done. I hope there are lots of questions.
Sir, thank you for a fascinating lecture. So you said universe is expanding. So for something to expand, it has to take up the neighboring space. So my first question is, what is universe expanding into? That's my first question. Secondly, we learn from black holes that there's too much density, there's too much gravity, right? And at the Big Bang time, there must have been many times more density, and consequently many times more whatever force you may name it, because you said gravity came later on. So what caused Big Bang in the first place?
देखिए, what caused Big Bang का तो हम नहीं बता सकते. We can only say on the basis of observational evidence that the Big Bang happened. But your earlier question, the universe is expanding, what is it expanding into? Answer is, it doesn't have to expand into another space. Take a balloon. The balloon has a two-dimensional surface, which means that if there's an ant, it can move in two different directions while remaining on the surface of the balloon. Okay, now that's an expanding two-dimensional space. You and I cannot imagine an expanding three-dimensional space, but mathematically we can. And so the answer to your question is that there is an expanding four-dimensional space, in fact. It is space, three-dimensional space, x, y, z, and t, time. It can be described mathematically, but it cannot be imagined because we are so limited in our imaginations.
Assalamu alaikum, doctor. Assalamu alaikum, doctor sahab. Over here. Sir, idhar.
By the way, Burak students get priority. हाँ लेकिन चलिए हाँ.
अच्छा, so आपने Doppler effect का जिक्र किया, and you said that was your first argument to support the Big Bang. You said how the Doppler effect implies a beginning, hence the Big Bang. What does it tell us about the inverse? Does it say anything about the ending, or do we just assume that it's going to expand indefinitely?
So the question is what will happen to the universe after a very, very long time? And initially there were three possibilities. One was that the universe would expand, and then stop. The other was, and then remain there forever. The other was that it would expand, stop, and then start contracting back and come back to the original point. The third possibility is that it expands, and its speed of expansion keeps increasing, and this is the accelerating universe. All three are allowed by Einstein's equations, but the third one is what is now experimentally observed. And so what we think will happen is that the universe will just keep expanding. As it gets bigger and bigger, it will get colder and colder. Eventually all the stars will die out. Eventually there won't be any light in the universe, and it will be a very bad ending. I'm sorry to tell you. But I don't know which you prefer. If you prefer that it all comes back together, then you'll die a heat death.
Do you believe that string theory will ever be solved? And if so, what can you comment on it? Do you ever believe that string theory will be solved? And what do you think the implications of it will be on how we perceive the universe and how we relate it to other things in physics and mathematics?
Well, string theory so far has not yielded any prediction which can be tested, but it does combine gravity with the other three forces, and it also tells us that space-time is actually very complicated, and in particular, when the universe was of very, very small size, that it had space-time was very curvy and bumpy, perhaps to the point where you can say that time loses meaning. So if string theory ever gets solved, we will be able to answer the question, what was there before t equals 0? Or even the question, does it make sense to talk about t less than 0? So let's hope and wait for the big people to solve string theory.
Firstly, I wanted to ask that since the Big Bang occurred completely spontaneously, is there a possibility of another Big Bang taking place while we are alive? And secondly, I also wanted to ask that I do understand that stars explode because of the shock waves inside of them, but is it because of the movement of particles inside of those stars, or is there something else or some other process that goes on within them that causes the star to explode?
Yeah, okay, good question. So inside a star, there is, the center of the star is extremely, extremely hot. If you take our sun, on the surface it is only, is very cool, 5,000 degrees centigrade, 5,000 degrees K roughly. Inside it is 10 million degrees or more. Now, there's such a big difference in temperatures between the inside and the outside that there are density gradients that exist. And when the fuel starts finishing, when you get out of the equilibrium situation, then something can trigger a shock wave. And that shock wave carries energy with it, a huge amount of energy. And this is what blew up that supernova which you saw over there. So there is a movement of energy and of particles.
I have two questions, I think. First of all, do you think humans have the capability to move to another planet and then evolve?
I think we are going to move to another planet very soon. In the next 500 years, maybe 1,000 years, Mars will be inhabited. There will be another kind of people living over there. Okay, they'll be like you and me, okay? But they'll be breeding amongst themselves. They have to. And they will evolve characteristics which will over time become quite different from people on Earth. So, yeah, the process of evolution will take a different turn.
So, do you believe in the Darwin's theory, and what's the fuel of stars?
What's that?
Fuel of stars.
Fuel of stars, hydrogen. But it's not just hydrogen, because when the hydrogen is over, or mostly over, then stars can burn helium. When the helium is over, then they can burn lithium, and they can burn in successive stages. They can't burn beyond iron, because iron is the most stable element in the universe. And your first question was, do I believe in Darwin? What? See, who am I to believe or not believe? The evidence is so strong, and there is no other competing theory other than saying that's the way it had to be. So if you believe in science, you believe in Darwin. If you don't believe in science, then don't believe in Darwin. It's as simple as that.
So I have two questions. First, did time exist before the Big Bang? And the second, is it safe to contact with other living beings in outer space?
I gave the answer to the first question just now, a string theory question. You know, the way we measure time, how do we measure time? घड़ी होनी चाहिए ना, घड़ी के बगैर तो आप टाइम मेजर नहीं कर सकते. ओके, घड़ी कैसी हो? तरह तरह की हो सकती है. एक तो वो हम पीछे लगी हुई है जो हमेशा गलत टाइम बताती है. नब्ज हम हाथ यूँ रख सकते हैं. ओके, व्हाट इफ there are no humans, there are no atoms, there are no particles, only strings. The other thing is that we know that space-time dances, can dance quantum vibrations. So time will lose meaning altogether. So before t equals 0, the question of time may not make any sense. Your second question, is it safe to contact outside civilizations? I think it's okay. There's no real chance of contacting them, and they're doing us any harm. But by that time, we're also getting smarter. If they're smart, we're also getting smarter with AI.
Okay, so I have two questions. So the first one was, so basically you said that the world had a lot of sulfur in the environment, and it produced a lot of poisonous gas, and oxygen and carbon dioxide evolved later. So how come it wasn't poisonous for humans? Like, how come it was like safe for us to live in the world, like with such gases around? And my second question is, do you believe in a parallel universe, like we're living in the Milky Way? So do you believe that there's like a whole different world out there in another galaxy?
Okay, the, the answer to the second question is probably yes. If what has happened on Earth produced you and me, then why can't it happen in some other galaxy where the conditions for life are similar and they fulfill what is needed for life to exist? And your first question was that?
The sulfur.
The sulfur, yes. So humans weren't around at that time. Remember, I'm talking of 3 billion years ago. You know when you and I came? Just abhi ki baat hai, 1 million years ago. 1 million, compare 1 million with 3 billion. That's, so answer is that at that time the only the most primitive forms of life were possible. We humans weren't there then.
Assalamu alaikum. So I was just wondering if you believe that there is life on or outside of Earth, do you think they would be similar to us or completely different, or what their way of thought or life would be? And then my second question is, do you believe in the multiverse?
First question is easy to answer. Highly unlikely that they would look like us. They would be adapted for the particular environment of their planet, and in all likeliness they would be very, very different from us. Where we would agree would be in the science that we do, in our observations of the universe. We would agree that there is such a thing as water. That water has a certain density, it boils at such and such temperature, at such and such pressure. We will agree on the structure of matter, the properties of matter, but we will not agree on anything other than that. And do I believe in the multiverse? Look, I keep an open mind on that. So I don't like it. Because if it's not testable, how do I know it's there? But I try to keep an open mind.
Okay, so Assalamu alaikum, sir. I read an article related to the Big Bang, which was actually rejecting the Big Bang as a theory, because recently there were 2 galaxies discovered which were older than the supposed time analyzed of when the universe was supposedly created. So what are your thoughts on that theory? And my second question would be that how can someone like us at Burak aim to be someone like you? And what steps did you take to be as educated as you are now?
Oh, it's very easy. Just read a lot of books. That's all.
What kind of books, though?
The ones you like. The other question is more difficult to answer. Look, when you say that those stars have a certain redshift, yes, one can agree on that because that's just optical, that's just looking through the telescope. But how far are they away? And so these 2 particular galaxies included, you have to rely on other kinds of evidence. And those evidences are that of the distant pulsars. And there it is not altogether clear that that is reliable. So in fact, you could, I think this is an interesting observation which those astronomers made, but it doesn't invalidate the Big Bang. It's more a hint that they should be looking at their calculations, they should be rechecking their calculations with other data.
अस्सलाम वालेकुम सर
बाकियों को भी देना है, इधर भी देना है, लेकिन हाँ.
Assalamu alaikum, sir. You talked about supernova and the formation of stars. Can you elaborate and explain it a little bit?
Okay. So, in a star, you have nuclear fusion, which creates heat. Heat causes gases to expand. Gases want to expand, but they are compelled to stay together by the force of gravity. Now, so there is an equal force outwards and an equal force inwards. Now, when that equilibrium gets shifted, what can happen is that matter can start falling to the center of the star. And when it happens, then it causes superheating, and that superheating then causes a shock wave to travel outwards. So this is something that is described by hydrodynamics and by the mathematics that Hans Bethe used to understand supernova explosions. It's, the study of stars is itself a full subject in physics.
I have two questions. The first one is that a particle with no mass travels at the speed of light, but the universe is expanding faster than the speed of light. The second question is, when the Big Bang happened, there was so much density at a small point, so wouldn't it form a black hole?
Okay. So that's a fair question, that there was so much density, why didn't the universe remain a black hole? Now, the black hole, the fact that it's not a black hole is obvious, because we live here, we can communicate with each other, we can communicate with distant galaxies and so forth. So it's not a black hole. The question is, why is it not a black hole? And the answer is that a black hole is made under very specific circumstances. So like a star which has run out of fuel, so it keeps shrinking and shrinking until it collapses. But the Big Bang had different initial conditions. So it's a matter of solving Einstein's equations in two different situations. And it's not this is something which involves time and is not static. Jana.
So we have experienced a certain form of life here on Earth. This is life as we know it. Life could have so many different forms. So why is it that when we're looking for life in the universe, we're always looking for similar kind of life, similar kind of conditions? Doesn't that limit our search, and isn't that a lack of imagination, that we're just looking for this kind of life?
We're not looking for creatures with two hands and two legs. We're looking for any form of intelligence. So if, let's say, you got a radio signal and you decoded that, and you found that it had the number 3.14159, what would you deduce from that? That somebody is out there measuring circles, radii, and finding that ratio is 3.14 is equal to pi. Lots of other things that can be conveyed by pure numbers. Of course, biological life is much more complicated than these relatively simple numbers, but at least that tells us that there's something out there which is intelligent.
Assalamu alaikum. I only have one question, that do you think humans will ever be able to do time travel?
Yeah. Actually, we do time travel. Every time you go around the world, there's a difference between the time that has elapsed for you as compared to someone who stayed at home. So, मगर फर्क बहुत मामूली है. You will have to be able to travel very, very fast for a long time for the difference to be noticeable. मगर time travel, yes, of course, you can go into the future. You can. माजी में नहीं जा सकते. माजी में जाओगे तो क्या होगा? बहुत खराबियां पैदा कर सकते हो ना. I mean, what if you go and you I will.
जी डॉक्टर साहब, मेरा सवाल ये है कि यूनिवर्स इज़ एक्सपैंडिंग, बट व्हाट इज़ इट एक्सपैंडिंग थ्रू और इनटू? क्या वो फेवरेबल कंडीशंस हैं इसके सर्कमफ्रेंस से बाहर जो इसको रोकती नहीं है एक्सपेंशन से? उसके बाहर क्या है उसके एक्सपेंशन से बाहर?
यही सवाल अभी हुआ है, हो चुका है, और उसका जवाब ये है कि हम किसी और स्पेस में एक्सपैंड नहीं कर रहे हैं, हमारा अपना स्पेस एक्सपैंड कर रहा है. तो ये फिर से मैं ये कहूँगा, ये फ़र्ज़ कीजिए कि हम एक गुब्बारे की सतह के ऊपर बैठे हैं और हमें खुद का, हम तो समझ रहे हैं कि कुछ हम साकिन हैं, कुछ भी नहीं हो रहा, लेकिन हम ये देख रहे हैं कि जो हमारा पड़ोसी इस तरफ है और इस तरफ है, वो हमसे दूर जा रहा है. जैसे जैसे गुब्बारा फैलता चला जाता है वैसे वैसे वो हमसे ज़्यादा दूर होते जाते हैं. मगर वो 2 डायमेंशंस है, हम 4 डायमेंशंस तसव्वुर नहीं कर सकते. तो ये सिर्फ मैथमेटिक्स की मदद से ही बात समझी जा सकती है. वी आर नॉट एक्सपैंडिंग इनटू अ 5th डायमेंशन, वी आर इन 4 डायमेंशंस. जी,
अस्सलाम वालेकुम सर, थैंक यू सो मच.
कहाँ?
Yes. So my name is Rizwan. I am a geophysicist by profession. I have 2 questions. I have listened most valuable questions that have been asked by the youngsters. Number 1 question: what is the way to think about the concept without time about that space? Second,
please explain.
I mean that how would a human being think about space without time?
Without time. Okay, so I think that somebody who dies probably loses the ability to understand that time is increasing, because then it is the perception that things are not changing, because the dead person is not receiving any kind of information from outside. And so तो ये हरकत का एहसास ख़त्म हो जाता है एक ऐसे शख्स के लिए जो मर चुका.
Thank you, sir. Second question is about how to relate the concept of entropy and expansion. Is there any possibility that after the completion of expansion there is another order?
This process of expansion will never finish. In fact, we are expanding faster and faster as time goes on. So entropy is continuously increasing in the universe. It may be decreasing on Earth because we are organizing things, but that's in a very small way. The entropy of the entire universe can only increase, can never decrease.
Thank you, sir.
Hello, sir. I would like to ask 3 questions, if you allow it.
अच्छा एक एक करके पूछो फिर.
Okay. First, you mentioned that in the beginning of the universe, there were antiparticles and particles, and they usually destroyed each other. So why is it that now when we look into the universe, we only find particles and not antiparticles?
Yes. So this is something that has worried physicists for a long time. That if the universe started off with equal amounts of matter and antimatter, why is the world made of matter today? And the answer is most probably that there is a small difference between the laws that govern matter as compared to antimatter. You can actually investigate this in certain physical processes, and this is called CP violation, charge parity violation in elementary particle interactions. But it's a very, 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 very tiny effect.
Because the universe is moving, accelerating, the speed of the universe is expanding, is accelerating. The particles are moving further and further away from each other at growing speeds. So that particle is basically moving faster and faster without a limit. So at some point, it's moving faster than light. But that's supposed to be impossible.
Okay, I understand your question. By particle, you mean particle, or do you mean stars or
Stars,
galaxies?
atoms, galaxies.
Okay, so nothing will happen to those, nothing is moving faster than light in those galaxies or those stars, but space, you correctly say, eventually will start expanding so fast that the rate of expansion, the speed of expansion will exceed that of light.
Has exceeded, rather.
And there's no problem with that. Fine. Einstein didn't say that, and we don't say that the postulate of relativity is that nothing can move faster than speed of light. Yeah, things can, but they can't be material particles.
No, but the universe is dragging those galaxies along with it. So aren't they also moving faster than light?
In fact, if one goes way, way back in the past, when the universe was expanding extremely fast, it was expanding at speeds which were millions of times faster than the speed of light. Remember, Einstein says you cannot transmit information faster than light itself. But there's no problem if space-time expands at any speed.
But it's carrying information. So
No, it doesn't carry information.
Aren't the particles that are on that space-time information?
No, I have. If I'm over here and I'm sending a message to some other galaxy, and the universe is expanding, that's it may or may not get through. Next question.
Last question is that Einstein said that space. Einstein said that space and time are connected. They are basically one field. So why is it that you can move any direction in space, but only one direction in time?
Yeah, that's actually, it's a bit of a fraud to say that space and time are the same. They're not. They can be made to look mathematically the same by going to imaginary coordinates. But see, the idea that one event comes first and another comes second. So I did one event, second event. That's not the same as being separated in distance. So time is not the same as space, but they get mixed into each other. You'll have to read relativity to understand that fully. Acha. Yeah.
Assalamu alaikum, sir. Sir, I want, over there, someone asked a question, and you said that there's some very specific conditions that have to be met for a black hole to be made. So I want to ask, what are those conditions, and what are other things that can happen to stars if their fuel runs out?
Okay. So good question. What can happen to stars is they can become bigger and bigger. In fact, what's going to happen to our sun is that as it runs out of fuel, it's going to expand and expand and ultimately eat up the earth and then contract back, but it's not heavy enough to be a black hole. So it will spend its life getting dimmer and dimmer. Nothing dramatic over there. But if our sun was 10 times heavier, I don't know exactly, but if it was much heavier than it actually is, then it would become a black hole. Okay.
Do you believe that the
we
theory...
should finish in 5 minutes. Huh?
Do you believe the theory that black holes may lead to other universes or wormholes is true? And if so, how do you think that affects how we see the universe and how we perceive black holes to be and the singularity that they possess?
Yeah. So you're talking about wormholes. And the idea there is that if you fall into a black hole, then time curves like this. But if there's a wormhole, then this neck will eventually spread out like this and join up with this. So you fall into a black hole, you can go out to a brand new universe or a distant part of the universe which otherwise you could never get to. The problem is that if I throw you in here, the gravity at the black hole center is so intense that rip you apart. So I don't think it'll work, but it's nice to think about.
Sorry, last one. Do you think the concept of look-back time will be useful in explaining all the questions proof that all the questions we've asked are true, for example?
Look back time?
Yes, like the concept of looking through a telescope, you're looking back thousands of light years. Do you think we could use that concept to find out how the Big Bang really started, or in more or something like that?
As it is, the light that we are seeing started billions of years ago. So that concept is built into our observation. Where the sun is right now, we think is right now, is where it actually was 8 minutes ago. It's we just are seeing its previous position. We can only look at history. We can't look at the present. Okay, so last question, absolutely. Okay.
I'm so sorry. I just had a very simple question. First of all, could you please repeat what happened after the third minute of the universe's development after the Big Bang? And apart from that, why are these 3 minutes so significant to us right now?
So these 3 minutes are significant because that's when neutrons and protons could form from quarks. Now, once the protons formed, they couldn't capture electrons at that moment, but when the universe spread out further and further, they could capture electrons, become hydrogen atoms, and then light would be able to escape without being scattered from these atoms. So that's the time when, and this is roughly 300,000 years after the Big Bang, not very long, but not very short either. And that's the time that the microwave radiation that we see today had gotten released. So that's a very significant time. Okay, so see you at 6 o'clock for the second lecture. Again.